All right, and now we're going to consider hyperbolas centered at HK, and they open up to the right and left. Just like when they're centered at the origin, to open up right or left, the x squared comes first. So that's again what we look for hyperbolas, to figure out what set of little formulas do we use. Is it centered at HK or is it centered at the origin? If it's centered at the origin, you use one set of formulas. Does x or y come first? That's what you got to figure out. That's that set. And that's what tells you what set of formulas to use. Here the x squared comes first, and it is not centered at the origin, so that's why we're using these formulas. Center is HK. This distance is a, just like in the earlier examples when it was centered at the origin. Well, to go from here to here, I got to add that a value to my x, because this is the x direction. So the vertices are h plus and minus a, comma k. Likewise, the foci are over here, and that distance is c, and I got to add that to the x value, add and subtract, in order to get my foci. Yeah. So there's the whole thing. So let's figure out, so what is a squared? Well, a squared is the number under x squared. It's 9. So a is 3. B squared is the number under the y component. The square root, b is 2. Let's find c. C is the square root of a squared plus b squared, the square root of 9 plus 4. So we get the square root of 13. Now we can answer our questions. All right, so where's the center? Where's the vertices? And where are the foci? Well, the center is at the point 6, negative 2, just like we did with circles. Positive 6, negative 2. The vertices are h, 6, plus and minus a. A is 3. So we get plus and minus 3, comma, negative 2. The foci are h plus and minus c. 6 plus and minus c. C is the square root of 13, comma, negative 2. And just like with circles and ellipses and stuff, there's two vertices. One is 9 root 2, 6 plus 3. The other one is 6 minus 3, which is 3 negative 2. Right, so everything's the same as we've done before, and there's our answers.